Okay, so here's a diagram that's in your textbook, and it just gives you a comparison of slope, roof slope here on the left, and the corresponding pitch on the right, which remember, pitch from a textbook would be the clear span between walls. Roof slope is the run or half of the clear span. So it's just a comparison. Okay, so you can see how steep these things are. Okay, the cornice. The cornice is the part of the roof that hangs out over the wall, where it rests on the wall. And there's three different types, and then within one type there's a number of variations. Okay, so the first one is what's called the open cornice, in which the tail of the rafter is exposed. Okay, and which let me back up. Whichever cornice style you're going to use totally depends on the look, the style of the home. Okay, so with the open cornice, the rafters are exposed, so you see them. So you have to have the freeze board, as it's called, which is a piece of trim that goes between the rafters. So you have to seal up the area there so that squirrels and birds and things don't get up in there. But then you would put a vent in every so often uh, to ventilate the roof. And these things, see, this one has a square cut on the end as opposed to a vertical cut, and they're often decorative. Something, it could be just the square cuts, or it could be something a little more decorative. Okay, the box cornice uh, is what you're going to see more often. And this one is what we call a narrow box, in which the end of the rafter has a vertical cut and a horizontal cut on it. And then the fascia and the soffit is applied directly to the rafter. Okay. Um, it's out there, it's done, but it's not common. Okay. Just because it's a lot of work to get these cuts exactly right so that the trim and everything lines up correctly. Okay, the wide box cornice is the most common that you see in houses, in which a what's called a lookout is nailed. It's horizontal. You've got a nailing header that goes down the length of the wall, and then the lookout is perpendicular to the wall, parallel to the rafter. Um, and then the fascia board goes on the end of the rafter, and the soffit gets applied to the lookout, and the ventilation gets put here in the bottom. This is the most common that you see, at least here in the southeast anyway, for houses for the cornice style. Um, okay, so here's another type, but it has a sloped soffit in which there's no lookouts. And so the soffit material is applied to the bottom of the rafter. Okay. And the distance of the overhang is just, whatever, the design comes out to be. Okay. Now, the third type being the closed cornice, is which there is no overhang. And this would be used often on like salt box style houses. Um, that's the one that comes to mind, and Cape Cods, some of those styles. And you'll see just driving around town, you may see a lot of houses like this. They have very little overhang. So they just get the freeze board and some trim and stuff applied to the end of the rafter at the exterior wall. Okay, so the soffit is this end here where the rafters rest on the wall. The other end is called a gable. Okay, and if it's a traditionally framed roof with rafters, you're going to have a different type of framing here on the end. But just understand that this is called the gable end of the roof. Okay, a hip roof would have eave all the way around. Okay, on a hip roof. Now, these diagrams have all been with traditional framing. What you see more often than not is roof trusses, um, because they go up quicker. They're quicker to install than a traditionally framed roof. And so here's just some common truss designs. And if you will notice, these are all designed so that the bottom chord, the horizontal part at the bottom, sits on the top plate of the wall. and then the top cord comes off with an overhang. So it makes it easy to build a box cornice, at your overhang. That's one variation, one way to do roof trusses. Now these create a rigid framework. They go up. They're typically 2 feet on center, and then there's blocking between them and attachings between them to keep them from leaning and to keep them straight. But they must be engineered for a house, and truss suppliers will do that. They'll take your floor plan and your roof plan, and they'll go into their software system and they'll generate a truss plan and calculate the size of the lumber needed, the length, the number, the spacing, and the design. Now, there's a lot of different type designs of trusses, so this is just a few of them. Mostly, these are made of 2x4s and sometimes 2x6s. It depends on the span that the truss has to span. So here's an example of the W-type truss. Um, is just how it's laid out. Okay, a fourth of the span here, a third of the span at the bottom. That's very common. For the rise, so for a 4, 5, or 6 inch roof slope, generally a 2x4 built truss could span 28 feet. A 2x6 truss could span 40 feet. That's just a general guide on that. Okay, now these things are held together with a gusset plate, which is a metal plate. You'll see this image in the textbook better. But there's a plate on either side of that joint, and there's a huge machine that presses those things together and sandwiches them together. It's got little spikes on the inside of the plate. That's how trusses are held together. Okay, here is another method of building trusses in which the bottom cord rests on the top plate, but the bottom cord extends out and creates the overhang and the soffit. So the truss itself creates the cornice. And then the top cord comes down and rests on top of the bottom cord. It doesn't show it here, but there'll be additional web members in here also. This is another method. And the difference between the two is that here, your soffit height is the same as your ceiling height. Okay, with the other trusses, the soffit height is lower than the ceiling height, and that makes a difference when you're planning your exterior elevations. Okay, but irregardless, most roofs have to have ventilation. Okay, and there'll be a vent in the soffit that allows cool air to come in, and then there'll be a vent at the ridge or near the top that allows the hot air to escape. Most houses will have attic ventilation. It's a relatively new thing to build a sealed attic in which there is no ventilation, no passive ventilation anyway, but you still have to allow for fresh air to get into the attic space because now it's conditioned space. And if you have a furnace in the attic, it has to have combustion air. Okay, we're not going to talk a lot about ventilation in this class. Our next residential drawing 1, we will get into how you calculate ventilation and plan for it. Okay, but we're going to skip over that in this class this time. Just to give you some examples of ventilation, the ridge vent is very common in a gable roof, and it has a screened passage of some type, and it just allows hot air to escape naturally because hot air rises. Okay. Another method is gable vents, and they have different shapes and sizes that go into the gable of the house. Okay. And so here's an example of some of the things. You've got these square, they're called saddlebacks or turtlebacks that can go on a roof. Cupolas, there's the turbine type that spin, and these all cooler air comes in through the eave and goes out at the gable or the ridge. Okay. Flashing, you're going to have flashing around your roof because no roof is waterproof. It is weather resistant, not waterproof. So it's designed to shed water. Okay. And wherever we have an intersection, whether it's a wall and a roof, chimney and a roof, or 2 roof planes like in a valley, you're going to have flashing to cover that area, and then the roofing will go over it. And there's some examples in the textbook, you know, of what flashing looks like. You just need to be aware you got to have flashing, okay? And at the eaves and at the gables, there will also be flashing at the edge of the roof. Okay, gutters. You all know what gutters are. Your dad may have made you climb up there and clean them out at some point in time. Okay, but the gutters collect the water that runs from the roof, takes it to a downspout, and then it gets directed away from the foundation. And the whole purpose of it is to get the water away from the foundation of the house, so it won't, you know, cause any foundation damage. All right, let me pause this video and then start another one.